Yeah, okay. All right. Can someone raise their hand and tell me what an extraneous solution is, please?
The statement is false.
The statement is false. The math statement is false, okay? So the idea that we've done in the past is divide by zero errors, have extraneous solutions, and square rooting a negative has extraneous solutions. Well, we have a new type now, okay? A new type of math error we haven't had to deal with before, okay? I want you guys all to try on your calculator to type in log 0.
So it's divide by 0 and square.
Square rooting a negative was an error, and dividing by 0 was an error. And we have a new type. Can't log a 0. Try logging a negative number.
Error. not
Okay?
answer.
So we have 3 main types of log errors that we have to be careful with extraneous solutions. We have square root of negatives, right? We have a divide by 0, and now we have the log of 0 or the log of negatives. Now, when we graph next week, okay, when we graph next week, I'm going to explain more why the log of 0 and negatives don't work. But for today, since we're solving algebraically, we just need to keep that in mind to check. Now, the reason I didn't have to bring up that on any of the other ones is because we weren't doing log equations, we were solving exponent equations. Does that make sense? Right? Exponents don't have restrictions. Okay? Their domain is all real numbers. But now we're going to go and do log equations, so we have to check for extraneous solutions. Okay? First of all, on A, what's the log base if it still says the word log and I don't see it?
10.
There we go.
W.
So I'm going to raise this as an exponent to a 10 on both sides. Why do you think I did that? What? Because they have the same base, and a log and an exponent are inverses.
Oh.
Now I have a nice linear to solve. And now I have to stop and double check, is that extraneous? If I plug 5 into either of these, do I get 0 or a negative? 3 times 5 minus 6 is 9. And 2 times 5 minus 1 is 9, so that one's good. That's actually my answer. Okay. We're actually going to go do D first because when I do B, you're all going to freak out because you hate negative exponents, so it's fine. So we're going to do D first. What do you think the exponent I should use on D? Don't break my heart. What's the exponent for ln?
Oh, it's E.
E, thank you. So I'm raising this as an exponent on an E to both sides so that I apply the inverse operation to a log, and I have to use the same number so that they cancel.
So E to the power of 0 is just 1.
E to the power of 0 is just 1. Very good.
5 minus 2x.
Okay, let's just pause here, make sure this makes sense.
W.
Now I can move the 5 over and divide by the negative 2, and I get x equals 2.
2 times 2
And do a quick extraneous solution check. 5 minus 2 times 2 is 1, so that's fine. Okay? Any questions so far? Okay, we're going to look at C. C ends up with an extraneous solution. Okay?
We have to do the power thing.
Good, Caden. You have to do the power rule thing first. I can't put the 4 exponent on both sides until I get rid of that 2. So first thing I'm going to do is move that up.
Do we have to break the 81 up? No.
The reason you don't have to break the 81 up, Caden, that's a good question, is because I'm not trying to figure out log base 4 of 81. I'm trying to get rid of the log, right? So it's not going to end up mattering. So now I'm going to raise both sides to an exponent of 4 so that those cancel, and I'm left with x squared equals 81. So what's the square root of x? Wait, that makes no sense. What's the square root of 81?
9.
And?
Plus or minus 9.
Plus or minus 9. 9 and negative 9. However, one of those is extraneous. One of those gives me a math error in this case.
Negative 38.
The negative.
Oh,
So that one is extraneous. So my only answer is x equals 9. If you're lazy and you forget about the minus 9 part, yes, Nathan, you're lucky on these ones. Okay. But that's not always the case.
I got lucky.
Because I can't take the log of a negative number. So when the negative 9 is plugged back in, I end up with the log base 4 of a negative number. Okay? All right, you ready for the negative exponent? You're going to have a mental breakdown?
yeah.
Yeah, maybe? You want a tissue? Okay, let's go back to B. What is my log base? 10. So when what is happening? What is this?
I'm just playing.
Wait, nailed it. Okay. 10 on both sides. So 3 minus 2x is 10 to the negative 1. Negative exponents move things to the other side of the fraction. So 3 minus 2x is 1/10. I'm pausing for questions or freakouts. No freakouts? We're okay? Reminder, 10 squared is 100. 10 to the first is 10. 10 to the 0 is 1. 10 to the negative 1 is 1/10. 10 to the negative 2 is 1 over 100. So now I'm going to minus my 3. Why do you think I rewrote my 3? Why did I rewrite my 3? Common denominator so I could subtract the fractions. Very good. You can write it like that. I just think it's easier to divide when it's an improper fraction. Do you guys know the dividing trick like that? Do you want to know the dividing trick? If you're dividing a fraction by a number like that, you can just double the denominator. Because what I'm technically doing is putting that over 1 and bringing it up to do the keep, change, flip thing, right? But it's a trick. Oh, and my negatives canceled because of the... there was a negative there and a negative there. Does that make sense?
Are these calculated aloud?
No. The ones we do next time are a little bit more. These ones are not usually. That one's not extraneous. I just checked for you. Hey, dudes. Great work.
Guess who actually accidentally did,
But now it'll make more sense. Yeah.
Can we have the following?
I'm going to extend the day on 7.3 since the sub didn't make it clear you guys had the accuracy quiz. Okay? So I'll give you through tomorrow at 5. Just in the basket, Elena. Ashley, you good?